I'm Catherine Faraon.
Problem for a surveyor is the calculation of the surface area of a specific field. The fields are often irregular, which makes direct calculation of their areas difficult. In such case, fields are divided into a number of regular areas, triangles, rectangles, etc., of which the surfaces can be calculated with simple formulas. All areas are calculated separately, and the sum of these areas give the total area of the field.
Materials: measuring tape, range post, plumb bump, chalk, and marking pins.
Part A. Area determination by base and altitude. Step 1. The instructor assigns the location of 5 points in the field, and the students will mark these points with marking pins or chalk. Name these points, which will serve as the corners of the polygon, as A, B, C, D, and E. Step 2. The chief of party divides the polygon into 3 triangles by taking into consideration that the division should be easily measured. Name the triangles as A1, A2, and A3. Step 3. Measures the base of the first triangle chosen in the polygon using tape, which is 16.50 meters. Step 4. Measure the length of the altitude of the first triangle. To solve this, we can use the 3, 4, 5 method, where we use the multiples of 3, 4, 5 as the measurement of the side of the right triangle. First, measure 30 centimeters on the altitude, 40 centimeters in base. Then, measure the distance between 30 centimeters and 40 centimeters measurement, and it should be 50 centimeters. If it is not 50 centimeters, adjust the position of the altitude until getting 50 centimeters. After that, we have now a right triangle. Make sure that the altitude side coincide to the opposite vertex. The altitude of triangle A4 is 4.4 meters. Step 5. Record the length of the base and altitude on table 3.1. Area determination by base and altitude. To get the area of the triangle, divide the product of the base and altitude to 2. Step 6. Repeat steps 3 to 5 for the chosen second and third triangles of the polygon. To determine the whole area of the polygon, take the summation of areas of A1, which is 36.30, A2, which is 45.88, and A3, which is 42.45, with a total of 124.63 meters squared.
Step 1. The same field described in A. Area determination by base and altitude will be used for this method, but change the designation on the corners. Use F, G, H, I, and J instead of A, B, C, D, and E. Step 2. Divide the polygon into 3 triangles as A1, A2, and A3. Measure any two sides of the first triangle chosen and record these measurements as sides A and B. Determine the included angle between sides A and B and record this on Table 3.2. Area determination by two sides in an included angle. Get the area of triangle, divide the side A times side B times side of included angle into 1/2. Repeat steps 3 to 4 for the chosen second and third triangles of the polygon. To determine the whole area of the polygon, take the summation of areas A1, A2, and A3. Area determination by two sides and an included angle. For A1, 34.24, A2, 61.49, A3, 57.92, and the total area of polygon is 153.65 meters squared.
Part C. Area determination by Heron's formula. Step 1. The same field described in A, area determination by base and altitude, will be used for the method, but change the designations on the corners, which mark it as K, L, M, N, and O. Step 2. The chief of party divides the polygon into 3 triangles by taking into consideration that the division should be easily measured. Name the triangles as A1, A2, and A3. Step 3. Measure all the sides of the first triangle chosen. For example, side A is 16.50 meters, side B is 8.30 meters, and side C is 9.60 meters. Record these measurements on Table 3.3. Area determination by Heron's formula. Step 4. Determine the semi-perimeter of the first triangle by multiplying the perimeter of the triangle by 1/2. To determine the area of the triangle, substitute the values of the semi-perimeter, side A, side B, and side C, to Heron's formula. Area is equal to the square root of S times the quantity of S minus A times the quantity of S minus B times the quantity of S minus C, where S is the semi-perimeter. The semi-perimeter is equal to 17.20 meters, and the area of triangle is 28.54 meters squared for the given example. Step 5. Repeat steps 3 to 4 for the chosen second and third triangles of the polygon. To determine the whole area of the polygon, take the summation of areas of A1, which is 28.54, A2, which is 70.12, and A3, which is 62.86, with a total of 161.52 meters squared.